Okay, here's another Raoult's law problem, but this one's asking you to calculate a molar mass. And so there's a little bit more work to do to dig deeper into the problem to figure out what information you have and what you need in order to calculate a molar mass. So don't forget that molar mass is grams per mole. And the problem clearly gives you gram. It says you have 8.30 grams of a non-volatile, non-dissociating substance. Okay, non-volatile, means Raoult's law works. Non-dissociating means that the Van't Hoff factor is 1. So you don't have to worry about that. You don't have to keep that take that into account. What you need to figure out is the number of moles of the solute in order to divide the two to get the molar mass. So now I want to go back to Raoult's law. The vapor pressure of the solution will be the mole fraction of the solvent times the pure vapor pressure of the solvent. So I've got the 8.30 grams. I just need to figure out how many moles of the unknown solute were in that 8.30 grams, and then I'll know the molar mass. So I got to do this through Raoult's law. Now, it tells me that the vapor pressure of the solution is 511 torr. The vapor pressure of the pure solvent is 526 torr. And so now I know the mole fraction of the solvent, 0.97148 with 3 sig figs. And so now I can put this together into the formula for mole fraction. I know that 0.97148 equals the moles of the solvent divided by the total number of moles. And that includes the moles of the solvent, plus it includes the moles of the solute. And that's the information that I'm missing. That's what I'm going to need for the denominator of the molar mass ratio in order to calculate it. So the rest is just algebra, 0.97148. Put that together in the ratio. It's conveniently given me 1 mole. I'm going to go ahead and drop the 0, just the 0.00 for ease, but it does have 3 sig figs. And so I'm going to take 1 mole, and then here's the x moles that I'm solving for. So let's go ahead and work on it algebraically. So I'm going to multiply both sides by the denominator, and then I'm going to run the 0.97148 through the parentheses. And then I can subtract the 0.97148 from both sides. And so I get 0.97148 times x moles equals 0.02852 moles. And so when I do the final division, I get x moles equals 0.029357 moles. And that's what I'm looking for. So I can go ahead and I can take that 3 sig figs, put that back in as my denominator, do the division, and I get 283 grams per mole. That's the molar mass of my solute. That's my final answer.